Hello, I'm Fergus Sinclair, Chief Scientist at the Centre for International Forest Research and World Agroforestry, as well as being co-convenor of the Agroecology Transformative Partnership Platform, the TPP, and on the steering committee of the Agroecology Coalition. And I'm talking today about how should we provide nitrogen to crops in the coming century. Now, we're just approaching COP28, and interestingly, food system transformation is expected to do some really heavy lifting in this COP. And it's not before time, because we know that food systems are responsible for about a third of greenhouse gas emissions. So food system transformation is fundamental to tackling climate change. But we know that climate change doesn't exist in a vacuum. There are a number of global challenges that all interact. There are broken food systems. We still have hunger on the one hand, obesity on the other across the planet. We have widespread degradation of land and water resources. We have catastrophic biodiversity loss. And all of these challenges interact very strongly with one another. And that's not just theoretical, it's now been measured in quite a clear way. So for example, if we look at the interaction between climate change and agricultural intensification, we can see it's the interaction that's really causing serious issues. 50% lower insect abundance, 20% fewer insect species as a result of that critical interaction, more prevalent in the tropics than in temperate regions. So, if we're going to address these interacting global challenges, then agroecology is really able to step up to the plate, because the 13 principles, as articulated in the high-level panel of experts of the Committee on World Food Security report in 2019, shows the principles cut across from the agroecosystem to the whole food system and address whole system transformation. And these principles, because they are explicit statements to guide action and decisions, are something that can be debated, can be revised, can be a clear statement of where agroecology is going and what it's doing. They're universal, but are applied through that central principle of co-creation of knowledge in local circumstances, creating a diversity of practice. Now, at the moment, these principles are being revised from the point of view of being more inclusive of water management and aquatic foods. And if you're interested in that process, please get on the community of practice for the Transformative Partnership Platform, and I'll show you how to do that at the end of the talk, and take part in that debate. There's an e-consultation at the moment on suggested revisions. And I'm going to talk a little bit later about the input reduction principle and how that interacts with the nitrogen issue. Let's be clear that the transformation of food systems is of whole food systems. So we're not only dealing with the production side, but also with consumption, what is consumed, linking production and consumption, and recycling and circular economy issues. And this is really important because there's a lot of transformation mentioned in the COPs that we've had up until now, but a lot of the time people are not really talking about transformation. They're actually talking about incremental change to a model which essentially isn't able to deliver against those challenges. And we'll see that specifically in relation to nitrogen fertilizer in this presentation. So, Why is nitrogen fertilizer critical in relation to climate change? Well, firstly, about 2% of all anthropogenic greenhouse gas emissions are caused by industrial nitrogen used in food production. That's about the same amount as the aviation industry, twice as much as the UK in a year, and it's about somewhere between 6 and 8% of the emissions from food systems. So it's a really substantial impact on the environment. Now, as we've seen, since climate change is aggravating a lot of the other global challenges, that environmental disruption in itself is very serious. But of course, also, there's nitrogen pollution that doesn't just affect climate, but also aquatic systems and other issues. So, it isn't also only the effect on climate change, it's also issues around food security. So countries that have been dependent on importing nitrogen fertilizer saw real food security issues when, as a result of the Ukraine war, the price of fertilizer shot up, threatening food security in a number of countries that were relying on imports. And of course, farmers locally found it extremely difficult to afford fertilizers. Governments that were subsidizing fertilizer use found it difficult to continue those processes, particularly where they didn't have sufficient foreign exchange. So this industrial model of providing our nitrogen to crops is unsustainable. Now, sometimes you hear, and particularly the fertilizer industry, suggesting that, well, the cavalry are coming over the hill because green nitrogen will solve all of our problems. But that really isn't the case, because it takes 25 times as much energy per unit of industrial nitrogen fertilizer produced from green hydrogen as opposed to grey hydrogen. And to put that in context, replacing industrial nitrogen production would take more energy than the entire renewable energy sources in the European Union. So it's simply not going to be possible in the time scale that is necessary for addressing climate change and reducing emissions to use green hydrogen to solve the climate relationships with industrial and production. So, do we have alternatives? Well, over the last 12 months or so, there's a lot of new evidence that's been published that really shows that you can maintain productivity without using industrial nitrogen fertilizer through diversifying our cropping systems and using legumes to substitute for nitrogen. This paper in Nature Sustainability looks at long-term trials across Europe and Africa, each with at least 9 years of data, so more than 25,000 data points. And it shows that productivity is positively correlated with crop diversity, and that you can substitute for industrial nitrogen in terms of maintaining yield when legumes are included in the mixture. And a global meta-analysis, again published in a Nature journal, shows with over 450 trials that legume rotations can substitute for industrial nitrogen by increasing yield across a large number of legume species and a large number of staple crops. And that's important because we do need different options for different contexts, and we can see here that there are a huge sway of options that may suit those different contexts that we find around the world. But we need to stress very importantly that it's not just a technology choice. When we think about the difference between industrial nitrogen and biological nitrogen fixation, a lot of things change. As we've seen, we need a complete transformation of the farming system, because what we are doing now is having a diversity of crops rather than a monoculture, and that leads to a whole set of different ways of managing the system. But also, we're moving from a centrally produced fertilizer that then needs to be distributed. People need to get access to it, to purchase it. Whereas when we're using biological nitrogen fixation, the farmer has the factory, if you like, the rhizobial association between the bacteria and the roots of the crop plants on their farm. So we're empowering farmers. They have their own system. But it is much more complex. It's much more knowledge intensive. There are lots of different legume species. They're being integrated into lots of different farming systems. And therefore, we need quite a lot of knowledge, and we also need to be able to manage the soil conditions so that there's enough phosphorus, that the pH is appropriate for the biological nitrogen fixation to work. So, much easier to stick some labile nitrogen from a bag and get a miraculous impact on a crop. More knowledge intensive, much more sustainable, and much more autonomy for the farmer, much more agency for the farmer if they're using biological nitrogen fixation. But we need a switch from the idea of recommendations and inputs being given to farmers to supporting local farmer innovation to be able to cope with this complexity and get the right fertilizer options, the right biological nitrogen fixation options for different farmers. Now, if we look at nitrogen fertilizer use around the world, we can see very different patterns with very high use, basically in the north, and the global north, and very low use, particularly in Africa. And that might make you think, well, in that case, it's not an issue for Africa. But it is, because Africa needs to improve the productivity of its agriculture, and either it's going to do that by using an industrial model and using more nitrogen fertilizer. So either Africa is going to need to use more industrial nitrogen in order to increase productivity, or it needs to find other ecological intensification pathways that will allow productivity increases without damaging the environment. Agroecological solutions that are in harmony with nature. And there are agroecological pathways. We can see here 4 different nitrogen fixing tree options being used in Malawi, and we see that for different farmers, different options are working well, and the same option will work very well for some farmers, not so well for other farmers. And this is critical in matching options to context. Now, a lot of our agricultural science over the past century has been about trying to find the mean difference and looking for mean differences amongst treatments. What we should be doing is looking at how context controls what works well in different places and for different people. And if we focus on that options by context analysis, then we find different options that suit different contexts. And that leads us to this really significant concept of different transition pathways, depending on where we're starting and depending on where we're going, and the context within which that happens. So the Gleesman transition, where you start by reducing inputs, has been very significant in the US and in Europe, because you're starting from a situation where you're using a lot of inputs. In sub-Saharan Africa, it's more a question of an ecological intensification pathway that is starting from a position of not using a large amount inputs. And recently there's an interesting paper in Outlook in Agriculture that Falconier and a very erudite and experienced range of agricultural scientists produced. And they are basically suggesting that the input reduction principle in agroecology doesn't work for mineral fertilizer in sub-Saharan Africa. And they're basically suggesting that in Africa, farmers need to apply more nitrogen. Now, I actually think that they have basically 5 reasons that they give for this, and I think we can see that while we can agree with some aspects of their analysis, it's actually flawed in a number of ways. Firstly, they suggest that sub-Saharan Africa is by default agroecological. But that's not the case. If you're nutrient mining, if you're degrading the system that you're working with, that's not agroecological. And you can intensify agroecologically, as I've just mentioned. It's not a question that a low intensity is associated with agroecology. It's a question of what you're intensifying in relation to. So agroecology tends to intensify in relation to knowledge, sometimes labor, and can get as high yields as industrial agriculture. But it's not primarily intensifying in relation to capital, which is the industrial model. The second point is about the nitrogen needs of crops, and they suggest that they can't be met using biological nitrogen fixation, but they don't quote any of the recent literature that I've just mentioned in this talk, and a lot of the measurements that they present are really quite old. And this is quite a problem as well, that there hasn't been the same sort of investment in measuring the amounts of biological nitrogen fixation that you can achieve. And so there is a skewed evidence base in relation to biological fixation versus the use of industrial nitrogen. So that's something that we need to be working on and putting more investment to understand better what can be achieved in terms of biological nitrogen fixation. There are also considerable areas of African soils where the soils are non-responsive to industrial nitrogen, and these are really problematic soils where we need to look at what remedial activity is necessary in order to improve yields. I think everybody would agree that soil management is absolutely fundamental to achieve high levels of biological nitrogen fixation, not just having sufficient phosphorus and potassium that the authors of this paper mentioned, but also controlling pH and basically good agronomy is really necessary in order for biological nitrogen fixation to be at the levels required to have high yields. And then there's the fact that they state that you can use mineral fertilizers without causing little harm to the environment. Well, I think we would disagree with that, including what I've just shown in relation to the production of industrial nitrogen, let alone what happens once it's used in terms of nitrous oxide release and so on. And finally, their fifth point is that if you do reduce the use of mineral fertilizers, you'll get lower productivity, and therefore you get agriculture expanding into forest areas and causing us problems with conservation. Well, that of course really comes back to the earlier point about whether or not you can fix enough nitrogen. I think that the data that we've shown suggests that you can, and in that case this issue doesn't arise. You can ecologically intensify without needing that industrial nitrogen, and then you don't have to expand into forest areas. So this brings us to this issue of whether input reduction is the best label for the principle that we have in agroecology. And in the HLP report, it's formulated as reducing or eliminating dependency on purchased inputs and increased self-sufficiency. Now, the problems with this as a universal principle is that reduction isn't universal. It depends how much you're using, whether or not reduction makes any sense. If you're not using anything, then obviously you can't reduce. And you can't keep reducing ad infinitum, because ultimately you won't be using anything. So while we are absolutely clear that it's critically important to globally reduce agricultural inputs, local transition pathways are really going to vary. So a possible more universal formulation of the principle might focus on favouring the use of natural processes over their substitution by purchased and environmentally disruptive alternatives such as agrochemicals. And that may be a clearer way of articulating that principle and guiding action and decisions. Now, in Europe, the use of nitrogen fertilizer is again a really critical issue in the news. Very prominently, the situation in the Netherlands is causing a lot of debate. And it's quite an interesting fact that the excess nitrogen, on average, applied to soils across the Netherlands is about the same amount as the industrial nitrogen that is used. However, we need to be really careful about averages here, because a lot of the excess nitrogen is going on to intensively used pastures in the form of manure rather than an industrial nitrogen, and a lot of the industrial nitrogen will be used in horticultural crops. But it is extremely interesting that the response in this European context is to try to buy farmers out of agriculture altogether, rather than to transform their agriculture to more sustainable alternatives. And perhaps an agroecological approach would be more sustainable for both the farmers in the system and ultimately our food production system. And we can look around the world at places where, starting from high input agriculture, effective transitions to a lower input agriculture have been possible while maintaining yields. Very prominent example of this is in Andhra Pradesh in India. And you can see here scientists and farmers discussing and getting together around the key mechanisms involved in natural farming, which is a set of principles of how to do agriculture that involves not using artificial chemical inputs, although they do make pesticides from local products like neem leaves and so on, and they do use an inoculum of cow urine mixed with various other components like jaggery, basically sugar, and they believe that this stimulates the microbial environment in the soil. And you're looking here at a transition from a very high input green revolution agriculture to not using chemicals. And in recent trials on the initial transition across the state, where we're measuring organic agriculture, natural farming, and conventional industrial agricultural production, and you can see that right across the state yields are maintained or increased with natural farming. And we actually can know what is causing this. It's more pronounced in the drier parts of the state, and it's because there is lower soil temperature, higher soil moisture, and more abundant earthworm activity associated with that yield maintenance. And we can see from other systematic review work, this one by Rachel Besner-Kerr and her co-authors, actually associated with the HLPE report. And this review showed that the food security and nutrition outcomes where agricultural practices were used were positive. In 78% of cases, and the more different agroecological practices that were combined on the same in the same area, the greater the impact, the greater the positive impact on food security and nutrition. So we can see that these individual practices translate into desirable outcomes. And that is reflected in the latest IPCC report, the sixth assessment, that identifies agroecology as a critical way to support food security, nutrition, health and well-being, livelihoods and biodiversity sustainability, as well as ecosystem services, and they have a high confidence in that finding. And the Transformative Partnership Platform, which came out of that HLPE report and a lot of other fora that went on during 2019, and it is a coalition, if you like, or a convening of research organisations, farmers' organisations around the world, looking at how to do agricultural and food systems research differently, using transdisciplinary approaches that involve stakeholders in the research process, that are problem-oriented, are looking for solutions, and are reflexive in their methodology. So we read this diagram from the inside out, starting with the locations on the ground, engagement landscapes around the world where agroecological transformations are happening, and then that being supported by global institutions and research centres. And together with the Friends of Agroecology in Rome and the Committee on World Food Security, the TPP incubated the Agroecology Coalition, coming out of the United Nations Food Systems Summit, only getting a look in at the last moment, but eventually, after a letter was sent to Agnes Kalibata, she agreed to put a session. It came in a graveyard lunchtime slot, but was very well attended and led to the development of a coalition of the willing, which currently has about 50 countries, including the European Union, the African Union, and ECOWAS as members. And the critical thing about the coalition is that because these are countries and organisations, there are over 100 organisations that are part of the coalition, because these are willing participants in a coalition, you're not held back by the lowest common denominator, by a country that is not happy with the concept of agroecological transformation, which often happens in fora that contain larger groupings. And so we hope that this coalition will lead the way and others can follow. And please, if you're not already a member of the TPP, do get involved in the community of practice and help us to take things forward and respond to your needs, as well as the many people who are already part of the coalition. Thank you.